Welcome back to 113 Racing, the only channel bringing you premium 206 content. So today I'm going to get started on the long-awaited video that I've been teasing for the better part of 2 years, modifying the subframe to get you more camber. If you've played with the 206, you'll know that getting the right amount of camber is a struggle. The easiest way to do it is with adjustable strut tops. They only get you so far and normally a half a degree away from where you want to be. Plus, the more you bring the tops of the struts in, the shorter your drive shaft gets until eventually the drive shaft runs out of plunge. It hits its maximum shortest point and it can't compress anymore, and then it has to start pushing the gearbox over and back, and that's probably not good. So there's a couple of different options for adjusting your alignment. First would be to just build a whole new subframe. These are only pressed tin, they're hollow all the way through. You could easily make a tubular version of this, which is better and has all the adjustment you want, or has the pickup points exactly where you want them. My class of racing, I'm not allowed to. I have to use the factory subframe. There's also quite a few elements that bolt onto this that have to be taken into account, but I mean, if you're handy enough with steel, it would be a great option. The second option is to make your own control arms, which would be better because these things are very, very heavy and not a great design. You could make something out of welded up sheet metal or possibly tube if you could fit it through the frame. That's better, and again has adjustment in it. You make it lighter because this is has to take all the torque this way. It has to be beefy here, but if you make a removable section that goes between here and here that bolts in, you can take a lot of that strength out of here and still fit it into the frame and then bolt that piece on later. Again, I'm not allowed to do that. What I am allowed to do is I am allowed to move my suspension pickup points radially, so in any direction from where they originally are, which is what I'm going to do. So I'm going to move them about 20 mil out using Camber bolts, which is the way sort of better designed suspension vehicles work with A-arm suspension. They've got a camber bolt in here which you twist it and it can move the front and back independently, and it can move it in and out. So I can also adjust a bit of caster at the result of changing my camber. So I can do a bit of both and I can get a perfect balance. When I slot these holes, I will also slot them slightly forward. So as I come out, I do go forward, giving me slightly more caster, which is better for racing, I'm told. So first thing I have done is tidy this up because it was covered in oil. If your 206 doesn't leak oil, it belongs in a museum, not on a racetrack. So once the oil is cleaned up, the second first thing to do is going to be to build a jig that locates the existing bolt holes. Because everything is, I'll bring you a little bit closer here, because everything's on different planes and it's all like lumpy and there's a mount in the way, you can't reliably, like you can't sit the control arm on there and mark the holes. And everything is, like I said, everything's on different planes. So they're on different levels. You've got a flange, a flange, a flange, a flange. So I'm going to plate these in so that they're flat and level, just to make things a heck of a lot easier in the future. But I need to be able to put these bolt holes back exactly where they are. So the first thing I'm going to do is probably just get some thin 1 mil that's easy to work with. And I'll make a big banana that comes around here and over here and basically picks up some existing features on the subframe so that I can lay it on, put a pin in that bolt hole and a pin in that bolt hole, and it will locate perfectly every time, and it will show me exactly where these holes are. And I can even elongate the template so that when I put it on here, I can use it to mark where I need to grind these holes out. So that's what we're going to do, and we'll get going on that right now. All right, this is what I've come up with. Now, if you know anything about me, you'll know that I hate using corrugated cardboard for templating because you can never get anything as accurate as you need to. This is a template of a template, so hopefully I can get it good enough that I can pull a decent steel template off of it. It's it's not exactly how I'd like it to be, so it's going to be a bit of a struggle. It also has a little bit of play even with all the bolts in, but we only need to be sort of within a millimetre of being right anyway, so hopefully we can get it close enough. So I'll transfer this over to 1 mil now, and we'll see how we go, because as you can see, everything's on different planes and it sort of needs to bend to conform, so I might actually take that piece out of it to make it a bit easier. We will see. I'll be back in a jiffy. All right, quick update what we got going on here. We've transferred the cardboard template over to steel. I modified it a little bit as I was going along. Basically used that template to get my rough shape, and then basically made this template from scratch because I wanted to fit a little bit better. So there's still a little bit of slop in these holes just because they're in single shear. It's kind of the way they are. I could probably trade that bolt out for an M12. If it fit, it might make it better, but it's good enough. These fellas go in to their factory location. Nice. This one here takes a bit of beating to get in there. I've got a nice edge here for reference, so I can get it on and off now. That's very loud. I can take it on and off now and get it back in exactly the same position. I did have it fitting really tight around here so that it would drop on and it wouldn't move at all. Problem is that because this is flanged out at the bottom, it wouldn't sit down low enough for me to get good reference marks on it. So I had to open that up so that it would sit down over the folds, and then it got loose, but it is what it is. I have pulled a reference line off the subframe, which is square. I double checked these holes against this flange here and against my mounting points, and they are definitely square. Although they don't look like it, they look like I don't know, they've got this weird pattern on them which looks out, but they are square. So I pulled the line across there. I've transferred the line onto here, which means that now I can take this off of here and I can elongate these holes in an outward direction. I'm going to go out and slightly forward. Not much, maybe a degree or two, just so that as it comes out, I increase caster. I've already got caster adjustment on the car, so I don't need any more, but as you come out, you always sort of want to come out in a forward direction, because you want, as you go out with Camber, you want more caster. So that's what I will do, and with this reference line here, I should hopefully be able to get both of them in the same orientation. With this template off of here as well, I can also lay the control arm on there and look down through the holes and make sure I'm going in the right direction. However, there is a bit of an issue with that, in that the bushes on these control arms obviously can move. So, you know, if they're not in alignment, they won't work anymore. So I've put this in and I've put the bolts through and I've got the bushes straight and removed it, and they're still pretty good. So you need to be aware of that. This spherical bush in here can be moved around. This one here will always, basically because of the rubber, will always sit straight, but this one here you can move it and it'll stay in its position. Being a new control arm, that spherical bush is extremely tight, so it's less prone to move. But if you're using an old flogged out arm, just be aware that they might not be 100% straight. All right, so I didn't do the best job of transferring these over, so the holes sort of get a bit wider at the end because I was going off track. So I just need to make sure that I use the front edge of this one and the back edge of that one, and then I can just come across 14 mil and get a new back edge, because at the back where the original hole was, the bolt's nice and tight, but then at the front it's got quite a bit of over and back slop, and I really don't want that. Now these are the Camber bolts I'll be using. They're from a D40 Navara. There's probably hundreds of different models you can use. They're just a standard M14 fine thread bolt with a groove in them, and the groove index is on the washer, so the washer can't spin, and that washer lines up with the welded on offset washer. And the way they work is this drops in the elongated hole, and then you've got a stopper which is welded on, which in my case I will clamp on. And then as you turn the bolt, it pushes against the stopper and it moves the bolt over and back. So you can imagine if you've got the control arm is bolted onto here, as you come out, it comes out, and as you turn, it goes back in. and there's another stopper of some sort welded out here as well. So you just turn the bolt and it just goes over and back like so. And I can draw that onto there and cut my elongations out and know that it's going to work. However, as I said, I'm going to weld on some reinforcing plates first. So this is one that I had cut out earlier. I believe it goes in there like that. Yeah, I don't know. I don't like it. I'm going to start again. I'm pretty sure these are 3mm deep. So we'll cut out some 3mm and we'll weld them in just to get this nice and flat. I'm going to cut this flange off here. And then when I weld my stopper on, I'll bring my stopper into here to tie this back in to make sure it's strong again. And we'll go from there. Okay, I've got both my templates. So now that I know that I can successfully locate these holes once I cover them up, we can start by covering them up. So I've cut a few of these plugs there, 32 OD. I'll drill them out to 16mm ID, 14mm ID, so that I can then put a bolt through it and bolt it in place. And then I'll just burn a MIG weld around the outside. I've cut them out of 3mm, although these are only recessed 2.5mm, so I'm going to have to grind the tops off. If I had some 2.5mm, that'd be ideal, but I don't. So we'll carry on. This one here, obviously the bolt, it's supposed to go through, but it doesn't. It stops there because of rust, I guess. But the washer clears here, but it's not going to clear when I get out to the other side, out to where it's going to be. So I'll cut this flange off here and all the way around, and we'll put that strength back in later. There's nothing on the inside here, so I can bring something down the inside instead of on the outside. And then we need to also level this one up as well. Or actually, I probably don't need to. I'll probably get away with not. But anyway, we'll see when we get in there anyway. I'm sort of thinking also, last time I just plated it basically out here like this with it. And then I put my block out here to hit my cam. However, I'm thinking I could probably do two things at once here, and I could probably make a piece that sits in nicely, and I could have a folded edge on it, a flange, which the cam rides on. So once we get this cut out, we'll see which way we're going to go. Might have forgot to hit record on that one. You guys are out of focus again, so that means it's time for me to quit. Did I need to TIG weld? No, I absolutely did not, but because I needed to grind this down anyway, it was already too high. I wanted to control my filler material better than what the MIG can. And TIG welds are easier to grind down than MIG, and you know, with a TIG you can also sort of move your puddle around it and level it out a little bit. It's just a lot easier to control. I also tied this fella back in on itself again, and I've cut this flange off of here, so I'll have to add something on the back side here, and I'm going to be getting very close to the edge here, so I'm going to have to add something on here as well, whether it's like a 90-degree flange or what, I'm not 100% sure yet. We'll work on that once I put this on. So we'll set that over the top. We'll grind those holes out where they need to be, and then I will reassess, but it's quite late, so that's going to be next weekend. That is day one down. Let's do it. Okay, so this little homunculus is what I've come up with. Maybe it's a parrot with a ponytail. I don't know. But anyway, I had a couple of different goes at prototyping it. This is my third one. I like using this sheet for prototyping, although that's a bit thick. It's a bit hard to cut. But if you can get this, in Australia it's called Galvabond. I don't know what it's called everywhere else. It comes in about 0.6 of a mil. You can cut it with tin snips really, really easily. And it's great for doing this because you can bend it multiple times and it will still sort of retain its shape. Whereas I bent this piece of 3 mil once when I bent it back straight because I missed the bend, it tore out. So had to make another one. But anyway, it sits on there perfectly. It needs to be bent so that it fits in nice. And I the reason that I screwed this one up was because I didn't really take into account how important the positioning of this flange is. And I just sort of bent it thinking I can, adjust it later with a bit of weld or whatever. But if that flange is in the wrong spot, it's going to limit my movement because the washer needs to push on that to go all the way in. So if I'm 3 mil out, I'll miss 3 mil of inward movement. So that flange is pretty important. So this is my third go. So I will photograph this one with a ruler as is, and then if it works, then I can do this one in CAD. But anyway, that's what I've come up with. I'm going to fold it up now and just see how it went. All right, since I'm far too lazy to lift my bender, I'll just use it on the ground, which is normally the case around here. If I go that one first, I can get in, or that one first. I'll do this one first. All right, cross your fingers. I hope this works. All right, so that goes in there like that. That goes there like that. Okay, that needs to be a little bit less folded. Should be able to do that just here. Okay, it's firm, but it's definitely in there. What I can see is it's riding up the back here. So I need to take some out of there. Maybe there like that. Let's take that out of there. And then I think we're good. Oh, and that needs to be folded there as well. So I actually need to bend that in 2 places because that's sort of got a bit of a curved profile to it. Take a little bit more out of there. But that's him. And that's beautiful. So now this should touch on the inside here when it's in position, which is right there like that. That is perfect. Perfect, perfect, perfect. Okay, so now the gussets are welded on the top side and I've got an area that's perfect for me to be able to slot. All I need to do is put the template back on, work out exactly where my slots need to be, and then I'll just drill and grind them out with the die grinder, belt file, whatever it takes to get those slots in there. And then I just need to put some sort of stopper on here for the washer. I will wait until the hole is ground out and then I can drop the bolt in and hold it up flush and weld it on so I don't lose any adjustability. I have been teaching myself CAD over the past few nights, like I said I would, and I've already got this drawn up and I've got these files drawn up as well. So I'm going to send them away, get them cut and delivered to me, and I'll use the files that I've made to do the other end just to make sure that they work before I sell them to anyone. And so while we're waiting for that, we can turn our attention to the back side. Now, the back side is easier but also harder. So the bolt almost drops in. Now, this one here obviously is a multi-plane thing again, so it's a bit bigger. But again, I'll put another washer like this in and weld it in just so that I get the same plane. This one here is already flat. Now I have designed a file to go in here to make the gusset. I might modify it, I think, so that it includes this flange, because I'm going to have to cut this flange off. But I think I'm going to do this the same way I did it last time. And if you're doing it yourself without any of the files, the easiest way to do it is to just cut off what you don't need and then put it back on, basically. So you can see it's not much. It's a little tiny bit of this flange. And in the past, I think I had a piece of 10mm plate and I welded, I think I actually cut this flange here and then I welded a piece of 10mm across here. And then I just ground out what I needed to suit the flange. I did the same thing here. I just welded a piece of 5mm, I think, on the back side here, and then ground out to match over a washer. So that's what I'm going to do on this one. But yeah, like I said, I will design something in CAD. I don't think I can match this profile here to actually put this flange in, so I don't know. It might just be a matter of having to do the same thing, having to weld a washer in, weld a piece of meat on the outside and then grind it in. I don't know if I can find a solution for that. If I do, it'll be available in the files. If not, this will be the process for it. Washer in, grind out, reinforce. So let's get to it. All right, that's somewhat tidied up now. So I'm going to use a combination of the slitting saw and the die grinder with a small ball mill to take out what I need to take out here to get this washer to be able to spin all the way around. So I've marked basically where it contacts on both sides and the thickness of it. And that's what I need to take out to be able to get it all the way around. I might need to take a bit more out. That's where I'm going to start at. Yeah, once I've got that done, then we can start slotting. Okay, so that recess is in there now on the bolt. Drops in and turns all the way around. So it protrudes about that far through the other side, which is not very much at all. So I'm in two minds as to whether I actually bend a piece of 3mm that comes down and around and ties all this in, or whether I just weld some 5mm on basically an angle like that and then grind it out. I think the bent piece of 3mm would be better. I haven't done this one yet. I figured while I'm going and while I've got the die grinder and everything going, I might as well mark out the holes and I can start doing everything at the same time. Unfortunate thing about this is because everything's on different planes, you really can't lay this flat up against it. So it's a matter of just sort of eyeballing down the hole, lining it up as best you can, and then making sure your marks go to the edge of your template on both of them. So you can see I've just lined the hole up all the way through, black mark around the outside, and then we'll just we'll come out to the edge of the black and then we'll just sort of gently massage it until we get something that fits kind of firm. So a lot more work to go. Let's keep going. Okay, now that the slots are cut in here, you can see just how little material there is in these webs here, and considering the main objective of our modification here is to not have the arm rip out of there, there's very little material holding that, and obviously, you know, that would tear out in an absolute instant. So at this point, if you're worried about this at all, for instance, if it was a part-time streetcar or something like that, what you could probably do is make up a plate that fits in the same spot that's maybe 8mm thick or 6mm thick, or maybe even thicker, maybe even 10mm. There's plenty of room on these bolts. And in fact, just thinking about that, I remembered that I actually had to continue these slots up here because they weren't long enough on the Navarro bolts, because we actually come all the way down to here and the washer doesn't go down firm. I actually need to bring that down. So you've got all that thread. So you can pack this up if you want, and probably not a bad idea. So you could probably put a plate that comes all the way out here in 8mm, weld it in. Make one that goes in here in 8mm, weld it in, give yourself a bit more thickness there, a bit more bite. The reason I don't is it's just so much work. Trying to get that slot in some thick plate and weld another one in on top, a lot of drama. And you can't just go straight over the top with heavy plate. I have considered that, but if you remember what we've got here, that's where the arm sits. So if you plate over the top of that, you're going to have a 2.5mm gap there, and when you tighten it up, it's just going to compress and squash. So you've got to have something in there. So you've got to weld a washer in first and then weld in a heavy plate. This one here could have been done out of 8mm, but like I said, just trying to get that slot in, you know, something thicker is a pain, and I'm not overly concerned. Once I weld in my my stoppers here, I'll bring them back into under here. You just need to make sure that whatever you put in under here doesn't interfere with you getting the arm in or out. So just do a test fit with your arm and work out how much clearance you've got to get some material in there. So these now drop in and go all the way over and back. Well, that one's actually a little bit firm. But yeah, what we'll have to do is once we've got the top slotted as well, we'll have to fit the arm and just make sure that it clears, because obviously if you've got it bolted at one end and this one here, it's going to want to try and move in a bit of an arc. Similarly, if you've got it bolted here and you try and move this one, it's going to want to move in a bit of an arc. So we'll need to just sort of ream these holes out bit by bit until we get it able to move into any position so that we can adjust camber and caster however we see fit without it binding up. So flip it over and we'll get on to slotting the top. I also haven't cleaned up that last weld that I did up here. So I'm fouling in here, so I need to clean that up so that my washer sits nice and flush. Another thing that I realized, sorry about the noise, is that when I welded this one here, I got it too hot and this piece here actually like sort of melted and collapsed. So now when you put the bolt in, you'll notice that I need to bring this back up. So I need to smack that back up before I weld my flange in there. Let's do those things. Let me stop that from leaking. All right, slots are done. I've got full range of movement in and out in a straight line, like all the way. This back one's binding up a little bit, so I'm gonna have to work on him. Now these bolts give you 12mm. I was a bit ambitious thinking that was 20, but anyway. So what I need to do now is weld these stoppers on. So if I adjust the bolts to all the way back, like that, put them back in the factory holes where we know the geometry was good and everything was fine. And then I can weld my stoppers on there, which means that I can always go back to the factory holes. And then when you turn this bolt, it'll push against that stopper and it will move the arm around. Now, when this is locked all the way back, I don't get full range out of each end. I only get about half. And similarly, if I lock this one back, I get about half the movement here. Now, I think that's going to be plenty, because if you watch how much this ball joint's moving, there's a good like 8mm movement there. I don't think I'm ever going to want that much caster adjustment. So I think I'm going to be fine, and I prefer to keep these holes as tight as possible to stop the arm wanting to slop around. It is going to, like, obviously this is going to be encapsulated in two stoppers, one front, one back, like so. But if it can move forward and backward in that slot, the bolts will vibrate loose. So the tighter the hole is, the better off we are. So I think I'm going to leave it as is. And yeah, so I'll just mark the back, weld the stoppers on, and then we'll reassemble it, and we can turn the bolts and make sure that everything has its 100% movement before we carry on. And then we can grind out any holes we need to from there. All right. So when I was in at work the other day, I picked up a few different things. Got a piece of 5mm, which I've already tried to bend in my little press and it's not bending, but I may have a solution for that. I got some 8mm, some 10mm, some 12mm, and some 16mm, which has previously been welded to the bench as a jig for something. So I think out of that, I'm going to be able to make something stoppers wise. I think probably maybe that's a bit too much on there. So I think maybe if I get that and just cut a slice off it, weld that on there. Also what I need to do is I need to make sure that my holes are long enough. So put the bolt in all the way that way, and then put the stopper on there, give it 1/2 mm clearance, hold it down, and then if we turn the bolt, it should automatically cam its way to the other end, which that's maximum there. So it's already hit maximum, and we'll make sure it's at the edge of the hole, which it is. It's got 1/2 mm play there as well, so that hole is perfect. With this one over here, I noticed, however, if we go in there, and that's where the stopper's going to go there. If we turn it around, it stops there, doesn't go all the way around. I don't know how well you can see that. So what we need to do then is look up from underneath, make sure that we're all the way in the original hole, which I can see that we are, because I can still see the original material there. So my plate isn't forcing the bolt this way, so we can get back into the original hole, which is as far back as I want to go. I want to come out more. So I'll grab my template, and I'll throw this back on, line it up with all the holes. Perfect, perfect, perfect. And I can instantly see where I've stuffed up. I have not clearanced that hole anywhere near enough. So can you see that? Yes, I need to take out more material here. So I will do that, and then I can put the top stoppers on there nice and easy. The thing to remember before welding these on is to make sure that these are relatively parallel. This does swing through an arc, but if you are not parallel, you'll be loose here, and then as it swings around, you'll get tighter. So you want to make sure that they don't have to be exactly parallel, but they want to be relatively parallel. So again, best thing to do, put the bolt in, clamp both your pieces on wherever I put them, clamp them on, and then swing your bolt through its range of movement, and just make sure that you're happy with where everything is. Got them welded on. Misjudged here a little and had to put a 3mm packer in there, but it is what it is. Had the welder turned up hot so that I could get the thick material melting before I hit the thin stuff, so I ended up putting a lot of weld on the thick and then flicking it into the thin stuff. So I got some ugly welds that I need to tidy up. That's just the nature of doing it that way, but for me it works. I've also got to grind out a little bit on the back side of those for the washers. Still, I haven't done that, so I'll flip it over and do that. And then we can do a test fit and see if it works or if I've wasted my time and yours. Let's do it. All right, so this is factory adjustment with the bolts all the way back. As I suspected, you can't go all the way forward with one with the other one all the way back because they want to move in an arc. You would have to elongate the holes this way. And I don't want to do that because it'll make the holes sloppy. I would prefer to just not have that range of adjustment and have the bolt holes tighter. If you ever needed to do that, you could ream your holes out for it. I can't see a situation where I'm ever going to need it. So we'll start by cracking off the caster adjuster so I can get my camber to move all the way. And then that's my camber adjustment there. So that's only going halfway because the socket actually hits the stoppers because the stoppers come up over the washer. So that might be an issue. You probably go down to 5mm stoppers so they're clears, but it's fine for me. And then caster adjustments. So that's a good 10, 12mm forwards and backwards, and a good 10, 12mm in and out. So that's plenty. We are binding if we go all the way out on both. It does hit in there, so that might be an issue. I don't think we're going to need anywhere near the range of camber adjustment this has, but I will double check it. We'll get an alignment, and if it's hitting there, I can clearance a little bit, probably out of the arm, because there's plenty of beef in these arms. If need be, we can just take a section out of the subframe and pull it out, or bash it out with a hammer, whatever. It is working. I'm happy with it. So yeah, I need to do a little bit more tidying up because they're binding a little bit, but aside from that, I'm very happy with it. It just needs to be put in the car and tested. All right, welcome back into 113 Racing, the only channel on the internet bringing you premium 206 modifications. This obviously is a 206 subframe. I say obviously, but you might not know. You might be a dumbass. I don't fucking know. I'm not questioning your life choices. I never record this. All right,